All right, what I have up here on the board is the 6 different types of decomposition reactions that you should have watched, and most people, well, not most people, all people had the video done. So good job on that. But the 6 different types of decomposition reactions are listed up here on your help sheet. Now, what I've done is I just printed off this help sheet. So I will get you a copy of this help sheet for you to put into your notes. But let's go over these first of all. And it's my opinion that decomposition is the toughest one because it requires the most memorization to understand what these products are being formed, what products are being formed during the decomposition. So we have metal carbonates, when heated, form a metal oxide and carbon dioxide. So we have a salt and give off a gas. You're going to see some similarities here. All right. A metallic hydroxide heated gives a metal oxide and water. Metallic chlorates heated give metal chlorides and oxygen. Metallic nitrates heated give metallic oxides, nitrogen dioxide, and oxygen. Oxyacids heated will give nonmetal oxides and water. And binary compounds, whether they're heated or electrolyzed, will give you the constituent elements, the 2 elements that that binary compound is made of. Now, one thing that you should notice is we have to have some sort of energy added for this particular reaction to occur. If you remember way back when to the lab, we did one of these labs where we drove off the oxygen. Okay? I think it was the percent composition lab, where we put potassium chlorate into a crucible, heated it up. We had to vent it so the oxygen could escape, and then we had potassium chloride left in our crucible. So you've actually already done this in the lab, but you didn't know that you were doing it yet. Okay? So, just like yesterday, we're going to go through 3 more examples of decomposition reactions. Okay, you should have had examples at least. I think you got 2 examples. So on your packet, you have 12 examples of these decomposition reactions. We're going to work 3 more just so we can go through and determine, all right, which one of these are we dealing with? So if I look, I'm going to start out with barium carbonate heated. Well, if I am looking at my outline, which one am I dealing with? 1, 2, 3, 4, 5, or 6? Which decomposition are we dealing with? Decomposition number 1. Okay? Decomposition number 1. So, decomposition number 1 tells me that I have a metal oxide being formed and also carbon dioxide. So now what I'm going to do is I'm going to put formulas to my words. I'm going to put formulas to my words. Barium is a alkali metal, right? Or it's alkaline earth metal. Yep. Barium's an alkaline earth metal, so it's a 2+. Carbonate is a polyatomic that is a 3-. Now, how we signify in a chemical reaction, folks, how we signify that something is heated is we put a triangle above the yield sign. So that triangle signifies we are adding heat to this. Now I can see that I have a metal oxide being formed. What is the name of my metal oxide? What's my metal? Barium. So my metal oxide is going to be barium oxide. How am I going to write? What's my formula for barium oxide? BaO. Barium's a 2+, oxygen's a 2-. BaO plus carbon dioxide. Now, probably something that we should get used to is that we know that carbon dioxide is a gas. So we could signify that as parentheses G, like I told you the other day. We could say parentheses G, that's a gas. We could also say, I don't know if I can sneak this in there without, well, okay. We could also say an up arrow like that, because that up arrow signifies that that also is a gas. My personal preference is the parentheses G. Okay. Now I look through this and say, do I have a balanced chemical equation? Yes, I do. So I have now completed the decomposition number 1 reaction of barium carbonate. My second example, sulfurous acid heated. Sulfurous acid heated. I look through my 6 and I realize that it is what decomposition? Decomposition number 5. We have an oxyacid heated. An oxyacid heated will yield what? What does an oxyacid heated yield? A non-metal oxide and water, right? A non-metal oxide and water. So, my first step here, going back to last chapter, or 2 chapters ago, I've got to name an acid, right? I've got to name an acid. So I look at this and I say, okay, sulfurous acid. That tells me I'm dealing with acid rule number 2. Acid rule number 2 tells me the base with the what ending? ITE. So I'm dealing with sulfite. What is sulfite? H2SO3. H2SO3 heated will give me a non-metal oxide. Now, my non-metal oxide and water. What I think, how I think of these, folks, how I think of these is simple math. Okay, I know that one of my products over here is H2O, don't I? I know one of my products is H2O. So what I look at is, okay, what would be easiest? Well, what would happen if I would subtract an H2O from H2SO3? What would I have left? SO2, right? Well, what a coincidence. Let's flop that in there. Is it balanced? Is it balanced? Yeah. There we have it. The final one that I'm going to do is aluminum chloride electrolyzed. This is decomposition rule number 6. Does everybody agree that's it, number 6? Okay, so what will happen? Well, this will decompose into its constituent elements. So that means it just breaks down into its 2 elements. So what is my formula for aluminum chloride? What is aluminum charge? 3 plus. What's chlorine's charge? What is chlorine? So it's going to give me AlCl3. Something a little different now. We are not heating it. We are electrolyzing it. So I put that little wavy line there. Now, let's just take a break here and let me explain this electrolyzing. Those of you that took IPS last year have done this. You had water, you put a power source onto 2 different leads into the water and collected gas into 2 test tubes. So basically what you did is you broke down water into hydrogen and oxygen. Then you did a test on it. You put a glowing splint in one of them and it lit up. That one was the oxygen. Okay? You lit a wood splint and stuck it in the other one and it made a little chirp, right? Anybody remember doing that? Okay? That is this. That electrolyzation, okay, was just the source, the little energy source that you put on there with the 2 different probes. Now, we're going to electrolyze that and split this into its 2 different elements. So it's going to give me aluminum and it's going to give me chlorine. What's going to catch you on this one? Chlorine's a super 7. So we need to make sure that if we're dealing with chlorine, we have Cl2. Can you see if you didn't put Cl2 how your balancing's going to be wrong? Now, is this a balanced chemical equation? It is not, because my chlorines are not balanced. I have to get this over here. I have to get this guy to an even number, which would cause me to put a 3 here to get both chlorines at 6. And then I would need to add a 2 in front of my aluminum right there to balance up that chemical equation. Now, Give me a thumbs up. We okay with this right now, or do we need to work some more? I can find more examples if you want to work them. I think that those three will probably be good enough from what I'm seeing with my thumbs. Well, not my thumbs, your thumbs. Okay? From what I'm seeing with your thumbs, I think that those three are good enough. So, you can take